this is the factorization for a difference of cubes, and here's the factorization for a sum of cubes. It's important to know common factorizations like these, so let's do a couple examples of each one. First, let's do a difference of cubes. How do we factor x cubed minus 8? First, we need to recognize that this is a difference of cubes. We have x cubed, and 8 is what cubed? Well, you've got to know that 8 is 2 cubed. So we can rewrite this as x cubed minus 2 cubed, just to see those cubes clearly. At which point, it's clear we have a difference of cubes, and we can apply this factorization where a is equal to x, and b is equal to 2. And that's the factorization. We have a minus b, which in this case is x minus 2. That's the difference of the two things being cubed, right? It's x cubed, 2 cubed, so we start with x minus 2. And then we have a squared, so that's x squared, plus the product of the two things, a and b, so 2 times x, and then plus b squared, which in this case is 2 squared, so 4. Here's a messier example, 16y to the power of 5 minus 250y squared. At a glance, there aren't really cubes here. Y to the 5, y squared, 16, 250, these are not cubes. So we should think about factoring out the greatest monomial factor. Clearly, both of these terms have a factor of y squared, and both of these terms also have a factor of 2. Thus, we take that greatest monomial factor of 2y squared out of both terms. That leaves 8y cubed minus 125, because 8y cubed times 2y squared would be 16y to the 5, and negative 125 times 2y squared would be minus 250y squared. Now this is a difference of cubes, and if we recognize that, we can use the factorization. We can rewrite it to make the cubes clear. 8y cubed is the same as 2y cubed, and 125 is 5 cubed. Thus, we see a, the first thing being cubed, is 2y, and b, the second thing being cubed, is 5. With this recognized, we can apply the factorization. So we have that monomial factor, 2y squared, that we took out, then a minus b, which is 2y minus 5, and then a squared, which is 2y squared, which is 4y squared, and then plus ab, the product of the two things, so 2y times 5, which is 10y, and then plus b squared at the end. B is 5, so b squared is 25, and that is the factorization. Now we'll do a similar example with the sum of cubes. Again, this is the sum of cubes factorization. In this first example, we have 27 plus w cubed. Hopefully you can recognize the cubes here. 27 is 3 cubed, and of course w cubed is w cubed. So a, the first thing being cubed, is 3, and b, the second thing being cubed, is w. Now we can apply the factorization. Beginning with a plus b, so 3 plus w, then a squared, so 3 squared, which is 9, and then minus ab, so minus the product of the two terms. Remember before we had plus ab, but now we're doing a sum of cubes, and so this is actually minus ab. Now a times b is 3w, so we have minus 3w, and then plus b squared. B is w, so w squared. Then again, we'll do a messier example, 5g cubed plus 320. 5 isn't a cube and 320 isn't a cube, so you may recognize we've got to pull out a factor of 5 from both terms. Doing that, we get 5 times g cubed plus 64. Now this is a sum of cubes, and if we recognize that, we can start to use the factorization. 64 is the same as 4 cubed, so we see that a, the first thing being cubed, is g. b, the second thing being cubed, is 4. Now we can apply the factorization, a plus b times, etc. And there it is. Don't forget we have the factor of 5 out front, then applying the factorization, we have a plus b, so g plus 4 we see there, and then we have a squared, so g squared, and then minus the product of the two things, so g times 4, so 4g, and then plus b squared at the end. b is 4, so that's plus 16. That's how to factor a sum and difference of cubes. Let me know in the comments if you have any questions, and be sure to check out my Algebra 2 course and Algebra 2 exercises playlists in the description for more. Thanks for watching.